to going through these, the easiest thing to do is to always draw the angle. Always draw the angle. If you draw the angle, it makes everything a lot simpler to work with. I know that we didn't have a big chance to talk about how to draw stuff in terms of radians. So I'm going to start with that, and then we're going to kind of go back into the homework when we were at last night. We're just going to add to it today, so don't freak out about any of that stuff from last night. So if I'm going back and just talking about how do you draw a radian angle, if we get through the idea of how that gets placed, finding coterminal ones becomes really simple, okay? So if I start with that first one, it says 2 pi over 9. What I want you guys to remember when you're dealing with radian measure, you have 0, pi, and 2 pi. This is pi over 2, and this is 3 pi over 2. Think of this as 1 half, 2 halves, 3 halves, 4 halves. It's always easier to think of it in terms of fractional value going around the circle, especially if you continue to keep a common denominator. It's just easier to visualize. This becomes one of those, this whole unit is extremely visual. If you have the ability to draw out a picture of where things become placed, it's much easier to see what is going on. This is one of those few occasions in math that visualization is just such a key. So if I'm looking at 2 pi over 9, is 2/9 more or less than halfway? It's less than half. So remember, this is half a pi, so this is less than half a pi, so it's going to be over here somewhere, I don't know where, but it's in this basic idea. It's up 2/9 over pi, okay? And I would just place it. That's how I would just draw that in what we call standard position. However you draw an angle is what you call standard position, okay? If I look at negative 7 pi over 6, with the negative, it tells me I'm going the other direction. I am now going to go clockwise. Same idea. Think about it in terms of how much pi is it? Well, this is 1 and 1 and 1/6 pi. This is, again, one of the very few occasions that mixed numbers make any sense whatsoever because it's very easy to count this way. So if I'm going to -1, I start at 0. Here's -1 pi. And now I have to go up how much off of this? A sixth. So, yeah, because because this would be half, it would be 1/4. You just think of it that way. So remember, you came up pi over 6 off of the x-axis. Now, whenever I'm moving these angles in standard position, I never really worry about labeling how far I am up off the x-axis in the first quadrant, because my angle is how far it is off the x-axis in the first quadrant. When I'm in the second or the third or the fourth quadrant, I always like to label how far up I am off the x-axis or how far below I am, because as we get into this whole idea of coterminality, if we understand the distances you're bounced off of the x-axis, it's so much easier to find that other value within radians. Okay? That's why I always take a second to write that down. So in this case, I am in second quadrant, looped around negative, came up a sixth off of pi. Not too bad. All right. 19 pi over 12, same idea. If I go 19 pi over 12, well, 12 goes into 19 how many times? 1, and how many are left? 7. So this is 1 pi and 7/12 pi. So if I go to place this, I'm going positive, so I'm going counterclockwise. Here's 1 pi, and then 7 over 12. Is that more or less halfway? It's past. So think about, if you think of it this way, here is 6/12. Here's 1/12 more. How much further would I have to go to get up there? To create, yeah, I'd have to create 5/12 more to come up. And that's the idea. How much further do you have to come up for a whole? The reason why I'm saying that is because it'll be easier then to find a negative angle when we do that in the next chunk. Yeah?
Would I write it as like 5/12 pi?
It's just, it is in terms of pi, and I
Okay.
was just saying it in my head, hey, that's 5/12 more to get to the whole. Because I'm always continually changing them into, 0, 6/12, 12/12, 18/12, 24/12. I'm thinking ahead of myself, trying to do it that way. Okay. Does that help with placing things within radian? Now, when we go into this whole idea of coterminality, were the degree measure ones okay? Or was there anything goofy with degree measure coterminals that you wanted to look at? We're okay on those? Just spinning around, spinning back and forth and all that? Not too bad?
Can you just go over like one of them?
Which one?
43.
Oh, I'm gonna do all the radian ones. I was wondering if you had any questions about the degree ones.
Like finding the coterminals?
Yeah.
Yeah, like could you do 43 for that one?
It's radian. I'm going to do the radian. Is there any of the degree one?
Oh, then I did those.
Which one? 780 degrees is 2 full revolutions. What's that? And then, I did that again. I did that last time. I was like, oh, that's it's turn around twice. That's 720 and then, thank you. Forgot. Anyway, so if you back this out, we know that here's 360, here's 720. What's left? 60. So this is 60 degrees off the x-axis, which means its first coterminal angle would be 60 degrees. You can do it one of two ways. By drawing it, figuring out how far off you are, it's a little bit easier to do it that way. Or subtract out 360 twice. And you're left with that. And that's fine. Now if I go the other direction, by knowing that I need to go a negative angle, by coming back around this way, I know that if I went all the way around, all the way around, this way, I'm sorry, I'm facing you, I'd have to wind up at 360 degrees, negative. But I came up 60 degrees of it, so it's at negative 300. And like you did, you subtract again, you would get the same answer. By drawing it and knowing where things are bouncing off those axes, it's going to help a lot more with the radian stuff. That's all, okay? Yeah? Whenever you find your first, all right, if this is kind of the rule, guys. If your original angle given to you is beyond 1 revolution, the coterminal has to be within 1 revolution.
Okay, so like for 37,
Yes.
I ended up with 570.
Perfect. Yep, that's fine, because you have to go beyond it, and then you subtract it, and that's fine. If your angle is within 1 revolution to start, you just add and subtract. If it's beyond, you'd have to subtract twice to bring it in, or add twice to bring it up. We'll get there. Yes, ma'am.
So for ones where you start with in 1 revolution, it doesn't matter if the answer would be.
Nope. Nope. Not at all. So let's look at the radian ones. When we look at the radians, first one to look at is 13 pi over 2. 2 goes into 13 how many times? 6. And how many are left over? So this is 6 1/2 pi, if you will. So when I go to draw this, 1 little, 2 little, 3 little pi, 4 little, 5 little, 6 little pi. Where does pi over 2 go? On the y-axis. Like that? That's good, yeah. So what happens here is you wind up on the pi over 2. You wind up on one of the axes. Now, anytime you land on an axis, the angle is what we call a quadrantal angle. We'll talk more about that next week. Quadrantal angles are your 0, pi over 2, pi, and 3 pi over 2, your 90s. Those are what you call your quadrantals. Now, they have special rules and special things that happen to them, and we'll discuss all that fun, so all of you guys will be gone. I got stuff for you, good luck. You'll see how it's going. Now, what's nice about being able to draw this, you can tell right away that your first positive one would be at pi over 2. We okay with that? You can subtract 2 pi and do all that as well, but a lot of times as you draw it, you see where it's placed, you know your positive is pi over 2. You go to your negative, it's going to be at negative 3 pi over 2.
Wait, so you can also.
Subtract 2 pi.
Wait, because that's what I did and I still like this.
Nope, it's fine. It's always easier to draw it and to see where you're landing because it forces it, because then you can figure out how far you've wound up off an axis or even on one, then you can know the specific value then. Yes, ma'am.
Can you explain how you got maybe
Okay, because I have to go, I'm going the other direction. So do you agree that this is half?
Wait, so do you start at the.
I start at 0 and I'm
You
going,
don't start at the top.
nope, this is 0. I start at 0 because this is always my initial side.
Okay.
So I go 0, negative 1 half, negative 2 halves, negative 3 halves.
Okay.
That's all. Okay. 4 goes into 17 how many times? How many are left over? 1. So this is 4 and 1/4 pi. 1 little, 2 little, 3 little pi, 4 little. Pi over 4 is that's halfway between 0 and 90, isn't it? It's 45 degrees. So how far up did I move that off of 0? Which is pi over 4. So that means my first positive coterminal angle would be pi over 4. The reason that it's within one, I had to go to within 1 revolution is because 4 pi over 4 is 2 revolutions around, so you had to back it up to wind up there. Okay. Now to go the other direction, you just count. Knowing that this is pi over 4 off of 0, if I go the other way, here's which is negative 7 pi over 4, because as you start thinking, this is 2/4, 4/4, 6/4, 8/4. I came up 1/4, so it would be at, negative 7 pi over 4.
So basically, when you just take like the whole minus the
Yep. That's why we bounce things off the x-axis, because you're either subtracting or adding depending upon what direction you're going for. It's a positive or a negative angle, and you're just adding or subtracting it to either pi or 2 pi or 0, whatever. Never ever worry about things on the vertical. It's always horizontal stuff to worry about. Okay. 24 pi over 7. We did that one yesterday in class, right? Sure. This one's weird because it's a 7th, and it's kind of it's a little bit of an oddball. 7 goes into 24 how many times? How many are left? 3. So this is 3 and 3/7 pi. So if I place this, it's positive. 1 little, 2 little, 3 little pi is 3/7 more or less than half. It's less than half. So this is going to drop into the 3rd quadrant. And I had to come off of the x-axis. I dropped down how much pi? 3/7. Very good. Okay. So now that means that my positive angle would have been, well, here's 7/7 plus 3/7 is 10/7. So it's 10 pi over 7. And then if I go the other direction, it's going to be very good. Now the reason why it's going to be negative 4 pi over 7 is because if you think about the idea that you start at 0 if you're coming backwards, you're coming backwards to negative 7 over 7. You agree with me on that? And then you just back up. And then you back it up that 3/7, so that's why you get negative. Okay. Yes, ma'am.
Do you need to write it 10 pi over 7 or like 10 over 7 pi?
Means the same thing. It's just more common to see it as 10 pi over 7. That's all. It means the exact same thing to me. Okay? Is that unfurling fuzziness?
Yeah, because I was trying to like minus 14 over 7 for that one, like 14 pi over 7, and like it took me so long.
It's so much easier if you can draw these. If you can draw it, and all you have to do is visualize how far it's dropping or raising above, and that way you know, are you adding or are you subtracting off of whatever values you're looking at, okay? The last one was 16 pi over 3. That one won't take much. 3 goes into 16 how many times? 5. 5, and how many are left over? 1. So you draw that. Are you singing the song as you're spinning around?
I will be on pause.
1/3 just drops again to the third quadrant. You are pi over 3 off the x-axis. Yes, sir.
How do you get the quadrant you're going to get? Because there's also the
We're just counting. 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. You know, I saw the Jewel ad yesterday. This is pretty funny. Jewel will have a sale on 8-inch apple pies next for $3.14.
That's awesome.
And they have a pie symbol cut out in the middle of the pie. Way to go, Jewel.
Yeah.
That's actually my mom's birthday too.
That's awesome. Your mom sounds cool.
Yeah, she is cool.
So with a positive,
She does.
All right, so shh, guys, the positive one would be, well, that would be 3 pi over 3 to go 1 full. Add a pi, and you're at 4 pi over 3. To go the other way, it would be negative 2 pi. Very good. Because you know that you're that far off of a full, you just back it up one. LeBlanc, you went cross-eyed there. You okay? Are you lying? What? Which? Explain.
I don't get this when you go the other way.
Okay. When I go the other way, this is still 0. This is negative pi. I'm going around. Guys. We know that the original angle was pi over 3 below that. So if I'm coming this direction, if I go a full to the pi, I'd come around to negative 3 over 3. Now if I backed it up a third, I'm at negative 2. I'm keeping it with the common denominators. Because this is negative 1, and I'm in thirds, so I might as well say negative 3 over 3. It's the same thing. That way I'm converting the fractions faster in my head. What I have for you guys tonight is just some more of the, what do you call it? Coterminals, drawing angles, placing it, stuff like that. I got answers on here and everything for you. There is other stuff as far as the sectors and angles and stuff we have not gotten to. All right, and we'll go from there. Those of you yahoos that are going to Ireland, 2 things. I have stuff for you, and you owe me postcards. No, you don't get extra credit. Why is that fair to us other knuckleheads that aren't going? I will say one thing. You are unfortunately missing some really important stuff. Yeah. I would try to do as much as you will go up flip it over. Try and get up through 32, because you don't know how to do sectors and stuff. What through 32? Up through 32. What's that? Yep. Exactly. Try. You're not going to Ireland, are you? No, you're not going to Ireland.
I'm in orchestra.
Yeah, that's what I thought. You're the cool person. What? I know. How stupid is that, right? Yeah. What I was gonna say is.